For each of the choices of f in Newton's second law, given by, it's given in equation 1.8. So equation 1.8 is this. This is equation 1.8. Now, we need to classify whether this is a linear or a non-linear differential equation. And says A, B, C, and K, they are all constants. So in part A, we have F is equal to C. And this is equal to N times dx squared over dt squared. So this is of the form dx squared over dt squared minus c is equal to 0, or I can just divide everything over by n, and I can have a form like this. So in this form, we can see that we still have a linear differential equation because the highest order term it's the only derivative that's present here, and it's raised to the power 1. So this is definitely a linear differential equation. Now in part B, f is equal to negative k times x. That implies this is still a linear differential equation because the second derivative of x and x itself, they're both still raised to the power 1. So it's definitely linear. Now moving on to part C. F is equal to negative ax cubed. So this is a differential equation we have. Now this term is fine because it's raised to the power 1. However, this term is not fine because it's raised to the power 3. And this makes the equation nonlinear. So C is nonlinear. In part D, F is equal to B sine of AX. So this is still nonlinear because we have a function that we have a sine function of x, and it's not just an x, but x is actually an argument in a sine function. So this makes the equation nonlinear. So moving on to part E, the last part, f is equal to a minus kx. That implies n dx squared over dt squared equals a minus kx, or I'm going to divide everything with by n. Is equal to 0. Now, this is a linear differential equation because we have everything x and its derivative raised to powers 1. However, this is not a homogeneous equation because you have a constant here However, if A is equal to 0, then it will become homogeneous. But we don't know what A is, and if A is a non-zero constant, then this equation is definitely a linear differential equation, but it's a non-homogeneous linear differential equation.